All right, so in this video clip, I'm gonna help you with finding the absolute value of a real number, and I'm also going to help you adding, subtracting, multiplying, and dividing real numbers. Okay, so once we completed this, I'm also going to introduce you to the powers, square roots, and the order of operations. All right, fun, fun, fun. All right, so let's start off by talking about the absolute value. Okay. Now, a number line will help us to understand the concept of absolute value and help us to see how to add and subtract real numbers. So take a look at the number line that I have here. As you can see, there is a zero in the middle. On the right side of that zero, I have all positive numbers. On the left side of the zero, I have all negative numbers. So, in other words, for any two numbers that are graphed on that number line, the number to the left will be less than the number that is located on the right of it, according to that number line, and vice versa. The number to the right will be greater than the number that is located on the left. So I'll tell you what, let's pick two numbers, any two numbers. So how about we pick a -3 and a -2? I'm gonna write it down right here. -3 and -2. See, it's in the order right here, according to the number line. All right. So as you can see, the number on the right, which is a -2, is greater than the number on its left, which is the -3. And it is here is where I will introduce you to the symbols that represents the greater than and less than symbol. So this symbol right here in this situation will represent the less than symbol because you see how it points towards that -3, and look how the mouth is open up. That's the greater than. Okay. So let's do a couple more examples. So I'm not going to put them in order. I'm just going to write the numbers out. I'm not going to put them in order in accordance to the number line. So what I'm going to do, I'm going to put a -3 over here. And let's put a 4 right here. So I can do this to represent the greater than symbol because 4 is greater than -3. As you can see on the number line. You see, if you look at the 0 right here, you go to the right, the number increases. If you go to the left, the numbers decrease. And that's why I say that the 4 is greater than -3. So let's pick another two numbers. Hmm, let's go with 2. I'm gonna put the 2 on the right side. And then I'm going to put a -4 over here. So I just want to represent the, let's say -4 is less than 2. You see that? -4 is less than 2. 2 is greater than -4. Okay? So let's move on. So what I'm gonna do, I'm gonna do not pay attention to what's going on this page right now. Don't pay attention to none of the writing, the diagrams, and the number line. I'm gonna explain all that later. So just block all of that out and just block it out of your vision. So now the absolute value of a number, for now, we'll just call that number X. Okay, we'll just call that number X. I'm gonna put it right here. That represents the number X. But the absolute value is written as this. This is how you represent an absolute value. Two bars on the side. Okay, two bars on the side. So basically, the absolute value can be seen as the distance from zero, the number of units from zero on the number line. Okay, so for example, the absolute value of -3, let's put it right here, -3, two bars. What is the absolute value of -3? Well, let's go where -3 is located at. This is -3. And how many units is it from the zero? How many units is from the zero? So we have 1, 2, 3. So the absolute value, let's put it right here. As a matter of fact, let me give us some space here. The absolute value of -3 is equal to 3 because it's located three zeros, 3 units from the zero. So what is the absolute value of 4? Well, we should already know this. How many units is it from 0? How many units is it from 0? Should be 4 units, right? One, two, three, 4. So the absolute value of 4 is 4. How about, let's see, how about the absolute value of -2? Let's put it down here so that way it don't get confused, get cluttered with everything else. So the absolute value of -2. Again, we do this. So the absolute value, the absolute, oh, did I put it? Okay, here it is right here. The absolute value of -2 is how many units it is from the zero. 1, 2. So the absolute value of -2 is equal to 2. Okay? But keep in mind, and this is important, keep in mind, the absolute value will always be positive or 0. Okay, let me repeat that. Let me repeat that again. The absolute value will always be a positive number or 0. And inside this blue box right here, this is the formal definition of the absolute value. Okay. So what I want you to do now, just stick around. I'm going to show you how to add, subtract, multiply, and divide real numbers. So let's start off with adding real number. Okay. So here you can see that I have two number lines. Both are different. The first number line you see, I have all positive numbers. You see that? I don't have no negative numbers. Everything on this top number line is all positive number. Okay. And the second number line that you see, I have positive and negative numbers. So let's start with the first number line. What I'm going to do, I'm going to pick two numbers. Let's pick a 7 and a 5. Both numbers are positive. And this two also represents the positive symbol. Okay? That represents the positive symbol. +7 and +5. Okay? Both numbers are positive. And that's how I got it set up on this number line graph. Now look at the number line graph on the bottom. Do you see how it has positive numbers on the right of the zero and negative numbers on the left side of the zero? So the first number line graph has no negative or zero numbers. Okay. So these are all positive numbers, which means that I can write the two numbers that I picked like this. +7 plus 5. But as you know, well, you probably don't know, but you don't have to put this sign right here to represent the positive numbers. Sometimes it's needed, sometimes it isn't. But for now, we will take it off right here so it don't confuse you. That's what we'll do. We'll take it off. All right. So 7 plus 5. All right. So let's see what we got here. 7 plus 5 units. 1, 1, 2, 3, 4, 5. 7 plus 5 equals 12. Simple math. I know it's simple math. But the reason why I'm showing it to you like this is because you're gonna run into some negative numbers where you might have to uh you might or you might not have to use a number line graph, but you'll get the concept because of what I explained to you earlier. Okay. Now, because both numbers are positive number, you don't need to display the positive sign. So we have a 7, and then we will move 5 units to the right, which give us a sum of 11. Now let us add some negative numbers. Take a look at the line graph on the bottom that has negative numbers on it. Now to add two negative numbers together means that we will be adding units in the negative direction, Or should I say head left on the number line graph? For example, let's add -1 plus a -4. -1 plus a -4. So what did that equal? All right, let's see. -1, and let's move 4 units. 1, 2, 3, 4. So do you see that? -1 plus -4 equals a -5. -1 plus a -4 will equals -5. Okay. Now, as a side note, and this is very important, when we are adding two real numbers with the same sign, such as negative plus a negative or a positive plus a positive, the answer carries the sign of those two numbers above for those numbers. So, in other words, if we're adding two negative numbers, then we will get a negative answer. If we're adding two positive numbers, then we will get a positive answer. I'll do a couple more examples. I'll do a couple more examples, which is before we move on to subtracting real numbers. So let us add 4 plus -5. I'll put it down here. 4 plus a -5. Okay. So let's get the 4 right here. So we're heading in the negative direction, right? So this is what we're going to do. 1, 2, 3, 4, 5. Up to the -1. Again, I'm not going to put another circle right here because it ended up at the -1. So I'll just go ahead and just draw a line right here. So 4 plus a -5 will equals a -1. See that? It carries that sign right there. Let me go ahead and erase this stuff right here because I'm gonna do some more examples so you can really get used to it, and that way it don't look so cluttery and confusing. Let's see. Let's think of a number. Let's go with a -1 plus 3. -1 plus 3. Let's put it right here. And what that equal? Okay, well, we're adding into the 3 now, right? We're adding into the 3. So we start off at -1 plus 3. All right, so -1 plus 3. 1, 2, 3. So a -1 plus 3 will give us a +2. -1 plus 3 will give us this +2 right here. Okay. Now here's a very important side note. If you are ever adding two numbers that look the same, but one of them are negative and the other one is positive, the answer will always be 0. So if you had a -5, if you had a -5 plus 5, it'll be 0. That equals 0. Even if you had let's see, a -3 plus 3, 0, 0. See that? 0. As a matter of fact, this is one of the properties that I spoke about previously. Remember the inverse property? But they call this the additive invert. So since we already know how to add, subtracting would be no problem. So I'm still going to go over some problems with you though. Okay. So for example, I will pick 0 minus a -3. 0 minus a -3. Let's put that in parentheses. You see, I intentionally did a problem like this because I wanted to show you something. Now look at that problem for a second. Okay. Now, do you see how you have a minus and a subtraction sign next to each other? You see that? Anytime you run into a problem like this when dealing with addition and subtraction problem, convert that into an addition problem. In other words, convert this problem to 0 plus 3. You have a minus sign and a negative sign next to each other. Same thing here. Okay? If you had a 2 minus, let's see, a 2 minus a negative, let's say 10. 2 minus a negative 10. Automatically, just look how it look. Automatically convert that into an addition problem. That's all you got to do. That's all you have to do. Okay, apply this method even if you have a problem. Apply this method even if you have a problem like this here. Negative 4 minus a negative 5. You see how these previous problems were all positive. We had a positive and we had a positive, but this here has a negative. But you still apply the same method, but you just carry the sign down with it. So it's going to be a negative 4 plus 5. You see that? A negative 4 plus 5. Okay? Let me do another one for you that has a negative number. Let's say negative 7 minus negative 10. Okay? Same thing. That's going to be a negative 7 plus 10. Negative 7 plus 10. Okay? All right, so now that I have gone over adding and subtracting real numbers, let's jump into multiply and dividing real numbers. Multiply and dividing uh, positive and negative numbers are simpler. I wouldn't even be surprised if you start taking a liking to these type of problems. Because when you multiply or divide, all right, so you see here how we have the same sign. Two numbers with the same sign, meaning a positive times a positive, or a negative times or negative, or even a negative divided by a negative and a positive divided by a positive, you will get a positive answer. On the other hand, if they are not the same, meaning they don't have the same sign, you will get a negative answer. It's that simple. So let's do some problems. So we have negative 4 times negative 3. Negative 4 times negative 3. Now, what did I just tell you? You're going to get a positive answer, which is 12. Let's write that down here. 12. But look at this. This is different. A negative 8 divided by a 4. That's different. So you're going to get a negative answer because it's not the same. So you're going to get a negative 2. These here are different. A negative 4 times a positive 5. You're going to get a negative answer, which is negative 20. Same thing here. A negative 3 divided by 6. A negative 3, a negative 3 divided by, oh my God, how can I say this? 3 over 6 divided by 4 over 12. Negative 3 over 6 divided by 4 over 12. So we remember how we do these type of problems, right? When we have these divisions on the side of each other, you do the reciprocal. It becomes a multiplication sign, you do the reciprocal. So this here you flip this over, and then you multiply these here together, which is good. So we already know that it's going to be a negative answer. So let's go ahead and put a negative sign here. So we multiply these two together, and we multiply these two together. So what we get? We get 36 over 24. I mean, we can reduce it. We can reduce it further. We can reduce it further. Okay. But we're not on reducing. Same thing here. Negative 3 over 6 times 4 over 12. Same thing. Same thing. Going to get a negative answer. Multiply the top, multiply the numerator, multiply together the denominator. So we already got our negative sign here. So we got 12. What's 12 times 6? Let's see. 2. Let's see. 12 times 6. 2, 1, 32. Let me go ahead and do this here so I know that you. Oh, God. What am I doing? Brain fart. Oh, my gosh. I'm way off. 2, 1, 72. 72. Sorry about that. Negative 12 over 72. This is different. This is different. Negative 10 times 5. So you're going to get a negative 50. But these here are the same. Negative 21 divided by negative 7 give us a positive 3. And there you have it. There you have it. Square roots, powers, and the order of operations. You're going to love this one. So I'll see you soon. Thank you.